Section 4 is going to go a little deeper into some of the trig ideas that you're going to encounter in Accelerated Algebra 2 trig or just regular Algebra 2. So there's some pieces called trig identities, and this is how the 2 or 3 different trig ratios relate to each other. And the first one is really an important one because that is the one that lets us find out what the tangent values are for various angles. And we do that by taking sine of the angle divided by the cosine of angle. So a lot of times when you're familiar with this, you hear us say tangent is sine over cosine. So if you know the sine and cosine values, you can create that fraction, simplify it, and then you get the tangent value. Another fun identity that is related to the Pythagorean theorem and the unit circle is that sine squared plus cosine squared is 1. And that is directly related to the Pythagorean theorem. And I'll mention that when we're talking about the unit circle. There are 3 other trig identities, and they are reciprocals of the 3 you know. So the cosecant is the reciprocal of the sine. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. And so really what we can talk about is that sine is equal to 1 over cosecant. Sorry. Is the right abbreviation? Cosecant. So when we're talking right triangle, SOHCAHTOA, sine is opposite over hypotenuse. That means that cosecant is hypotenuse over opposite. Cosine is adjacent over hypotenuse. That means that secant is hypotenuse over adjacent. Tangent is opposite over adjacent, so then cotangent is adjacent over opposite, or 1 over the tangent. They are reciprocals of each other. So that is an important feature when we start talking about the rest of the trig family. So let's talk about this fancy thing called the unit circle. Now, on a unit circle, let's talk the basics first. We are still talking about a coordinate system, but instead of talking x, y, we are going to talk cosine, sine. So our x values are cosine, and our y values are sine. So this axis is our cosine axis, this axis is our sine axis. We have a radius of 1, and so this point right here is at 1, 0. This point at the top is at 0, 1. This point up, sorry about that. This point out here is at -1, 0. And the point at the very bottom is at 0, -1. And that's how we can work our way around a coordinate system. So when we start thinking about degree measures, we're talking about the fact that starting here, we're at 0, or all the way around is 360. At the top, we're at 90 degrees. Halfway across, we're at 180. Another 90, we're at 270. So we have our degrees all the way around. So putting this together, we can talk about the cosine of 0 is 1. The sine of 0, or the sine of 360, is 0. In the same way that we can talk about the cosine of 90 is 0, the sine of 90 is 1. And you can check those in your calculator. But if you have those values memorized, it's a lot faster. So let's go in and look at some of these triangles created. and then talk about the reference angle part. So if we look first at this red right triangle right here that we build, and if I tell you this is a 30-degree angle with a hypotenuse 1, we have a 30, 60, 90 triangle. And so here is our short side, here's our long side. And so we know our hypotenuse, and if you remember that the hypotenuse is equal to 2 times the short side, so in this case our short side is 1/2, and then our long side is equal to our short side times the square root of 3. So we have the square root of 3 over 2. Now those are the lengths of those sides, and if you combine that with how you move on a coordinate system, I'm going to go over this x value, which is the square root of 3 over 2, and I'm going to go up this y value, which happens to be 1/2. And so we get the ordered pair square root of 3 to 1/2. Now, if we think about graphing in general, in quadrant 1, x's are positive, y's are positive. In quadrant 2, x's are negative, y's are positive. In quadrant 3, x's are negative, y's are negative. And in quadrant 4, x's are positive, y's are negative. So that then tells us what our sine and cosine values are. Positive, positive, cosine, sine. Cosine is negative in quadrant 2, sine is positive. Both are negative in quadrant 3, and in quadrant 4, cosine is positive, sine is negative. If we go back and think about that tangent being sine over cosine, when we think about the signs on our tangent, tangent is sine over cosine, tangent's going to be positive, 2 positives. Over here, if tangent is sine over cosine, plus over minus, tangent's going to be negative. And when I go down here, a negative over a negative, tangent is going to be positive. And when I come over to quadrant 4, if I have sine over cosine, I have a negative over a positive, my tangent is going to be negative. Now, the reference angle part of this, if you look, I have red angles that all coincide. These are all 30 degrees. And so if I did the math, they would all have the exact same length out this way of the square root of 3 over 2 and height of 1/2. So every one of these ordered pairs is the square root of 3 over 2, 1/2. The only thing that changes is in quadrant 2, my x's are negative. In quadrant 3, they're both negative. And in quadrant 4, just the y is negative. That is a reference angle. And so what happens then is I'm also going to compare all of that to the x-axis. If I go up 30 degrees, I'm at 30. I started at 0, I went up 30. If I start at 180 and I back up 30, this is a 150-degree angle. So the cosine of 150 is negative square root of 3 over 2. The sine of 150 is positive 1/2. If I start at 180 and I go this way 30, 180 plus 30, I'm at 210. If I start at 360 and I back up 30, I'm at 330. So the cosine of 330 is positive square root of 3 over 2. The sine of 330 is negative 1/2. So tune into part 2, and I will talk about the 45s and the 90s.